Hello, students of mathematics. Welcome to this differential calculus lesson where I will be showing you how to differentiate functions using first principles. Okay, I believe you have your pen and paper ready, and let's go for it. We have the first principles here, as I've written right at the top in green for us, where we have a formula basically that allows us to calculate the gradient at a point of a curve or of a function. Okay, so what does it say? It says the first derivative of f, hence the word first principles. Okay, so first derivative of f at some point x is equal to the limit of h approaching 0. This h just means horizontal distance, okay, between the 2 points that you are using to evaluate, approximate, or calculate the gradient of this function. So 1 point is some horizontal distance away from x, and you are getting the vertical distance between them, because remember, f of x is another notation for y. So the difference between these two numbers right here, or these two expressions, give you the vertical distance between these 2 points. And then, of course, there'll be some horizontal distance apart. So this ratio basically comes from our basic knowledge of gradient, where you are saying changing y over changing x of these 2 points that lie on the graph. Okay, so this is the language of calculus that we use when we talk about the gradient of a function. Okay, so let's start. Where are we in the book? Definitely we're here, Inquiry Approach to Mathematics, and I'm discussing the problems in page 201 all the way to page 203. Okay, so let's start. We need two expressions here to be able to effectively use this equation here. So we need the expression for f of x plus h. We need the expression for f of x. Okay, so let's see, how can we get the expression for f of x plus h? This tells us that in the function f, where we see x, we now substitute x plus h, because it is now for our second point, or the other point that we use to move closer to our reference point, so that we can evaluate the gradient of the function at the point of interest. Okay, so in place of x, we're going to now substitute x plus h to x plus h. Okay, the operation here is a multiplication, so distribution needs to happen there. We have 2x plus 2h. Okay, and what do we have? We now have this expression. We also have this expression from the equation itself. So we are ready to apply first principles, okay? To do what? Get the derivative of the function. So let's start. F prime of x is equal to limit as h approaching 0 of f of x plus h minus f of x over h. Okay, and then you have limit as h approaches 0. F of x plus h is that expression, so it's 2x plus 2h minus f of x is that expression for f of x, so it is minus 2x. Okay, so I encourage you, in your substitution for f of x, always use brackets, because sometimes, for instance here, you need to take care of the sign changes, okay, because we have a negative right here, but since it's a monomial, we can leave it like this for this case. So this is over h. So what do we notice here? After our substitution, the substitution is followed by cancellation of some terms here. Okay, 2x minus 2x will disappear, and we are left with limit of h approaching 0 of 2h divided by h. Okay, and then again, this is cancellation that we make for h, because that must be 1, of course. H divided by h is 1. And then what are we left with? We are left with a limit of h approaches 0 of 2. Okay, so this is a constant function independent of h, so no matter where you evaluate the change in the horizontal distance, you'll always get 2. Okay, so what does this tell us? The derivative of the function at some point x is equal to 2, okay? And if you compare it to the expression of f, this is a linear function, and you'll remember that a linear function has this format: y is equal to mx plus c, and this m is our 2 that is given there, and hence we get the gradient of a 2 here being equivalent to m in the expression of a linear function in standard form. So here we go for a linear form. This is what we do in finding its derivative, okay? And it must make sense. So you can always remember that for a linear form, the constant or the coefficient of x will always be the answer that you are aiming to arrive at in terms of being correct for such a question, okay? So great. We are ready to go to number 2 now. Find the derivative of the function g. Okay, look at this, it's g, it's not f. So in our labelings, we must make sense to the labeling of the function itself. So we have the following: we need to find the derivative of g, but first we need the expression for x plus h. Okay, so what will this be? We have x, of course, in place of x, and there are 2 places or 2 terms that contain x. So you need to substitute twice this x plus h in that expression. So we have this x plus h. What are we doing to this x? There's a square there, so we square this one. Plus 2 times, what are we doing there? Really the coefficient, or actually the exponent is 1. So we leave it as it is. We don't change the meaning of the function. We are just making a substitution here into the function. Good. So you expand the binomial, you get x squared plus 2xh plus h squared. Distribution happens here, you get 2x plus 2h plus 1. Okay? Any like terms that we see here? Nope, there is no like terms. So we go straight to our formula. It's a g. So we're not finding f prime, we are finding g prime. Okay, the first derivative of g, okay, at some point x is equal to limit as h approaches 0, not of f but of g, x plus h minus not of f but of g of x all over h, and this is equal to limit as h approaches 0. Now the expression for g of x plus h is that expression right there for that. So we have x squared plus 2xh plus h squared plus 2x plus 2h plus 1. So we gotta be careful here because we are dealing with many numbers. So now the red expression, we are now substituting it, and because it's a trinomial, it's more than one term, I advise, as I did with number 1, to use brackets. Okay, so you bring in your brackets and you bring your expression for g of x now, and then x squared plus 2x plus 1. That is the substitution for g of x, and then this will be over h. Right, so I'm just going to go to the left a bit here for space, and then we have limit of h approaching 0. After substitution, usually we have cancellation. So let's check for cancellation. Okay, let me use purple for that. This x squared minus x squared will disappear, and then 2x minus 2x will disappear. 1 minus 1 will disappear. So the entire expression for g of x is no longer part of our expression in the numerator. So we just write down what is left: 2xh plus h squared, these 2 terms, plus this little guy right there, plus 2h all over h. Okay, and then what do we notice? In our numerator, we have an HCF, h, h, h. Okay, so we factorized it. Our highest common factor there is h. So we bring it to the front, or we factor it out, limit of h approaching 0, and that is now our factor. We're left with 2x plus h plus 2, okay, all over h, okay. And again, we can see the h over h cancellation happens, it's 1. So we are left with what? This is equal to limit h approaches 0 of 2x plus h plus 2. So this expression is definitely dependent on h. So we can make a substitution and take the limit. When you take the limit, just like here, we drop the notation, okay? So you drop the notation, you take the limit, and this becomes 2x plus, in place of h, you plug in there 0 plus 2, and then the answer becomes 2x plus 2. Okay, so this is telling us what? The derivative of g is equal to 2x plus 2 at some point x. And what which function is represented by this expression? It's a linear function, okay? So the gradient function of a parabola or quadratic function is a linear function, okay? So you go 1 degree less, and in our later lessons you will see that process and that relationship in the differentiation rules, okay? So yeah, this is it, guys. Linear function, quadratic function, and I'm now moving on to a cubic function, okay? You find it on page 203. So I'm going to do a cubic function now. Okay. So for this one, we have f of x. Okay. So this is our third example. F of x is equal to 4x cubed. What do we need? We need our expression for x plus h. We have f of x. Okay, so solution. We want to differentiate this function using first principles. So we have f of x plus h. We only have one term that contains an x, so the substitution will only take place at one term. But this x is cubed, so our substitution here for f of x plus h must also be cubed. Okay, now here you gotta be careful because this is 3 of this binomials. Okay, x plus h, and then x plus h. All right, and then you can decide, are you gonna use the first 2 binomials or the second 2 binomials and take care of the other one later? So I'm gonna go like this, focus on that, and then here the distribution of the 4 can happen, and then we work like that. Okay, so I'm just gonna go a bit to the left for space. 4x plus 4h. We took care of that first bracket there. Okay, and then now in our red bracket, what is happening? We have a square of a binomial, x squared plus 2xh plus h squared. So after expansion, this is what we get as the resulting expression. Okay, so I believe you're following with me and we are enjoying mathematics because math is fun, right? Good. Now we have a binomial times a trinomial. Again, we need to be careful, all right? So our term, first term, must be multiplied by everything in the red brackets. So we have 4x times x squared plus 2xh plus h squared. Okay? And then our second term, the positive 4h or plus 4h, must be multiplied by everything in the red bracket as well, plus h squared. Good. Then we distribute. We have 4x cubed plus 8x. Look at this, 4x times 2x squared. So the exponential laws will come into play here, because x times x is x squared, and then there's an h there as well. 4x times h squared, this will just be 4xh squared. Good. Plus, then what's happening here? 4h times x squared, just 4x squared h, plus 4h times 2xh, 4h, and the h there will produce for you an h squared. So it is 8xh squared, okay? And then plus 4h times h squared is 4h cubed, okay? Let's look for like terms. We have x squared h here, we have x squared h there. We have xh squared, we have xh squared there. Good. Let's reduce our expression then to become 4x cubed plus 8 plus 4 is 12x squared h, and then the 4 plus the 8, again we get 12x h squared now, and then we have this guy right here as well. So this is the expression that is fully simplified. It does not contain like terms. So you're now ready to go into your first principles. So let's start. We have f prime of x equal to limit h approaching 0 of f of x plus h minus f of x all over h. Good. So now this becomes limit as h approaching 0. Of course, this is the expression that represents what? F of x plus h. So then this becomes 4x cubed plus 12x squared h plus 12xh squared plus 4h cubed. Good. Now we are coming here minus the expression for f of x. It's just a monomial and it's positive, so it's just minus 4x cubed, like that. All right, so we divide both sides by, the entire expression by h. Okay, what do we look for? We look for terms that are cancelling, because after substitution we usually get cancellation. All right, so look at this, 4x cubed minus 4x cubed. So those two are gone. What are we left with? We have limit of h approaching 0 of 12x squared h plus 12x h squared plus 4h cubed over h. Okay, now we check that we have any highest common factor here in our numerator. Yes, we do. However, what do we want to cancel? We want to cancel an h. So even though 4h is our highest common factor here, we only take out the h because we need to cancel the h as our denominator. Okay, because if you take out the 4h, you will again redistribute that into your brackets and sort of like go back to where you were. So then we take h always as our factor, because the horizontal distance is a distance that we are interested in at this point, most closer to that one, and we are evaluating the gradient here, okay, when the horizontal distance approaches 0. Okay, so we have limit of h approaching 0. We take out our h, and this is 12x squared plus, we have two h's there, so it is 12xh plus the 3 h's there, so 2 will be left, and this is over h. Okay, and then the cancellation there will happen, and then we are having an expression limit h approaching 0, an expression that is dependent on h to 12xh plus 4h squared. Okay, so when we take the limit, we're going to substitute there and substitute there for h, and this one, or this term, is independent of h, so we take the limit, we drop the notation. Okay, so then this becomes 12xh plus 12x times 0 plus erase that part, plus 4 times 0 squared. Okay, then these 2 will disappear, they are 0, and the answer, sorry, just made a mistake here, it is 12x squared. Okay, and this 2 will disappear, we are left with 12x squared as our answer. All right, good. So what is this telling us? The gradient of a cubic function is a quadratic function, a parabola. Okay, as you can see, it's 3 goes to 2, we go 1 degree less. Okay, so guys, this takes care of differential calculus with respect to differentiating functions using first principles. I believe this was helpful to you, and I look forward to having you on in our next lesson again. Thank you for tuning in. I'll see you next time. Sharp, sharp. Good.